Okay, the next bit is about spread. So far we've talked about one way we can describe a set of data, and that's with the mean, so our central amount. But these two sets of data here, so it's production from two different plants in a company. We've got Acheron plant and Glenwy plant, and the mean is 55.75 for both of them. So if all you looked at the mean, you would say that both plants or both factories were doing about the same. But if you look at it, Acheron's got a greater spread, and it's even got one value quite low there, whereas this one here seems to be much more consistent. So we use the standard deviation to analyse, describe and compare spread. So the standard deviations for these are 11.0 for that and 17.2. So that's where the spread comes in handy. So let's have a look at how we compare our income prediction. So this is what people thought that they would earn themselves, or they thought that the class would earn. So the standard deviation, and you don't use standard error. I've put a line through that, and sometimes people just see, because it says standard, they just use that, but a standard error is something different that we'll be talking about later to do with confidence intervals. In fact, you never have to use it. Standard deviation is this one here. So for the individual earning was 96. For the average class income was 34, 35. So let's have a think about that. When people estimated what they themselves would earn, there was quite a big spread over what they thought. Some people thought they might earn $30,000 a year. Other people, $1.5 million and things like this. But when they came to estimate what the class would earn on average, it was nowhere near as spread. Can anybody think why would that be? And this is not actually reality, this is just people's perception. It was actually very interesting because I think probably when people are looking at averages, they realise that when you've got a group of people, you'll have some high performers and some low performers, and it will sort of average out in the middle. And so what it's shown is that the class as a whole actually has an underlying idea of the central limit theorem. So what the central limit theorem says is exactly that, is that if you take the averages will not be anywhere near as spread as the data as a whole. So say I got each of you to write down, I don't know, how much money you've got in your bank account at the moment for the whole class here. You all write it down on a piece of paper, and I just take a sample of 6, and I find the average of it. And then I take another sample of 6 and take the average, take another sample of 6 and take the average. Those averages will not be as spread out as what you've written down as a whole, because whoever wrote the smallest amount, which might be, say, negative $100,000 or something like that, will be balanced out by the other people in the group who don't have as low as that. So I think what's happened is that people perceptually have actually, or intuitively, have thought about that. So it seems that there is an understanding underneath of the central limit theorem. Okay, now I have this long-standing discussion with Irene David from the Stats Department, who believes that students should be expected to calculate the standard deviation by hand because that will help you to understand it. And I think you don't, because I don't think that actually learning how to calculate it helps you understand what it is. So I'd be interested in your opinions if any of you have ever been taught to calculate the standard deviation. You guys over there, you playing cards or something? Yeah, maybe you could do it elsewhere. Okay, where the standard deviation comes from, it's rather like an average deviation. So what happens is that for each of the values, you find out how far does that value deviate from the mean of the data. So we're looking at, on average, how spread out are these observations from the mean. So what you do is in Excel, we just get it in the data analysis, or we use the formula STDEV. There are two different formulas, one for population and one for sample. If we're doing sample, we use n-1 here. If we do population, we use n. Now, you don't need to know this because we will just about always be dealing with samples, and hopefully they're so big it doesn't make any difference anyway. In Excel data analysis, it will always find the sample standard deviation. It assumes that you're dealing with a sample. You don't need to do this by hand. This is the formula. So for each value, you subtract the mean, you square that difference, you sum them all up, you divide by the number of things, and then there's a -1, which you don't even worry about, and then you find the square root again to get rid of the whole squaring thing. Now, you might ask yourself, why do we bother about the squared bit? Why don't we just add up all of the differences between the value and the mean? Well, the interesting thing is, if you do that, the answer is 0, because the mean is such that it will be 0, because the mean is found to be the value that will occur when these deviations are 0. So you can't just sum up the deviations, and then you say, well, okay, well, sure, you've got half of them are bigger and half of them are smaller. Why don't we just find the absolute value? Get rid of the minus sign and use that. And that's a reasonable thing, and it's called the mean absolute deviation. And it's used in some things because it's easier to calculate. But in fact, squaring it is quite good because it sort of punishes large deviations more than small deviations, and it works in a particular way mathematically that makes it very nifty. And later on, when you do later statistics, they use this particular idea a lot, and it has been found to be a very good way to do things. So that's as far as we're going to go mathematically, is that this is what's happened. For each observation, you find out how far it is from the mean, and you square that deviation, you add them all up, you divide by the number of observations, and then you take the square root. So hopefully you've got an idea there of what the standard deviation is.